After Pro.
Hi guys, this next video is all about unequal resistors in series connection connected to a voltage source. Solving unequal resistors in series connection, there are following conditions that prevail. Okay, for the number 1 condition, the current through all resistors is the same, meaning that I total is equal to IRs of 1, which is equal to IRs of 2, and also equal to IRs of 3, and also equal to IRs of 4, and also equal to IRs of 5. So the number 2 condition is the total resistance of the circuit is equal to the sum of the individual resistance, meaning that R total is equal to R1 plus R2 plus R3 plus R4 plus R5. Next guys is number 3, which is the circuit current or I total is equal to S of t divided by Rs of t. And for the number 4 condition, the voltage drops across the individual resistors are directly proportional to the magnitude of respective resistance. We have the formula S of x divided by S of y is equal to Rs of x divided by Rs of y. This proportionality is derived from the fact that S of 1 is equal to I multiplied by R1, and S of 2 is equal to I Rs of 2, S of 3 is equal to I Rs of 3, and etc. So for example, S of 1 divided by S of 2 is equal to I Rs of 1 divided by I Rs of 2. Cancelling I, then we will have S of 1 divided by S of 2 is equal to R1 divided by R2. So it follows that S of 2 divided by S of 3 is equal to R2 divided by R3. Also, S of 3 divided by S of 4 is equal to R3 divided by R4. And also, S of 4 divided by S of 5 is equal to R4 divided by Rs of 5. Then the last condition guys is that the total circuit power is equal to P of t is equal to S of t multiplied by I of t, or P of t is equal to I of t multiplied by S of 1 plus S of 2 plus S of 3 plus S of 4 plus S of 5. Okay, so now we go to the examples. A series circuit consists of 3 resistors R1, R2, and R3 connected to a 120 volt source. If the voltage drop across R1 is 30 volts, when the circuit current is 2 amperes and R2 is equal to 1.5 of R3, calculate the values of R1, R2, and R3. So we have the given S of t is equal to 120 volts, V Rs of 1 is equal to 30 volts, and I1 is equal to 2 amperes. So the solution is Rs of t is equal to S of t divided by I of t. R total is equal to 120 volts divided by 2 amperes, which result into 60 ohms. Then R1 is equal to B Rs of 1 divided by I of 1. So B Rs of 1 is equal to 30 volts and I1 is 2 amperes. So 30 volts divided by 2 amperes, which result into 15 ohms. So R1 guys is equal to 15 ohms. So now solving R3, since R2 is equal to 1.5 of R3, so we have R total is equal to R1 plus R2 plus R3. Then substituting the value of R2, which is 1.5 R3, then we will have R total is equal to R1 plus 1.5 R3 plus R3. So substituting the values, we have 60 ohms is equal to 15 plus 1.5 R3 plus R3. Then we will have 2.5 R3, which is equal to 45. Then the answer is R3 is equal to 18 ohms. Then solving R2, which is equal to 1.5 R3, since we already solved the value of R3, we have R2 is equal to 1.5 multiplied by 18 ohms. So R2 now is equal to 27 ohms. So guys, as a summary, the value of R1 is equal to 15 ohms, the value of R2 is equal to 27 ohms, and the value of R3 is equal to 18 ohms. So guys, as a summary of solving unequal resistors in series, we have number 1, the current through all resistor is the same. Number 2, the total resistance of the circuit is equal to the sum of the individual resistance. Number 3, the total current is voltage divided by total resistance. Number 4, the voltage drop across the individual resistors are directly proportional to the magnitude of the respective resistance. Then lastly guys, the total power is total voltage multiplied by the current.
Hey guys, thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.